Well, hello everyone. Welcome back to Adrian's Digital Basement 2. It's a super mini mail call episode, and it's been a while since I've done any of these. And most of the items that we're going to have on today's episode are things that were given to me in person at VCF in Dallas. Now, that was all the way back in June, and you might be wondering, like, why am I only showing this stuff now? Well, unfortunately, I think I've talked about this on other videos. I picked up some kind of a GI bug when I was in Texas, and I came home and I was pretty sick for like a week or two. Then I actually got COVID as well, and that was here. And then that took me off for a little while as well. So it really kind of put me behind on all my video making. So I've really had to focus on getting videos made and getting them released, and it's kind of why I haven't really focused on the Plexus much. It's sitting back there. There's a lot that's happened on the Plexus since I've last covered that, which has now been a few months now, and it's going to take me a while to sort of catch up on all the developments that have happened there so I can wrap my head around it and make a good video. And I know I don't really have to do this, but I try to release videos on schedule, so that's one every Wednesday on the second channel, which is what you're watching here, and then one every Saturday on the main channel. Well, when I put my head down, I really start to focus on one thing, then everything starts to slip. So between the catching up from being sick and then all the regular life stuff that's going on, plus there's been summertime trips and things like that I'm going on, I just haven't had as much time as I certainly will have once winter happens and it gets a little less nice outside, so I'm not going to be out riding my bike and going on road trips and things like that. So with all that said, let's get stuck in to some of these items. So the first item is a package of Haribo, and you'll notice that, well, this one looks a little bit different. It's all in German, and yes, this was actually brought to me and handed in person by a commercial airline pilot for Lufthansa who actually scheduled his flights around the VCF event happening that weekend so that he could come to the event and experience all the retro stuff that was going on and then apparently say hello to me. And his wife picked out these Haribo for me, and he brought them on the flight all the way to Dallas and then gave them to me. So that's pretty awesome. And unfortunately, I didn't write down the name of the person that gave this to me. I usually try with a Sharpie because otherwise I will immediately forget. So if you're watching this, hello and thank you very much for the Haribo. It's been down here in the basement unopened where it's nice and cool at like 21 degrees all the time. So that means that the candy is still perfectly good. Now, it's been a little bit of time since I've had any candy on the channel, and I really do appreciate it when people do send it in. I'm a type 1 diabetic, which means, you know, I generally don't eat candy. Although, as a type 1 diabetic, again, if I have low blood sugar, which happens if I give myself too much insulin, then I do need to eat something sugary to bring my blood sugar up. So it's juice or something sweet like candy, ice cream, things like that. So I always have stuff stocked in the house just to be able to eat if I have that low blood sugar, and it can happen anytime. So I always try to keep candy in the car, for instance, stuff like that. So this is really good. So I'm going to like divvy this up and put it around in different spaces or places so that I have something to eat. Although the one negative about this is there's a lot of licorice in here, black licorice, and that's not really my thing. So I may pick and choose a little bit and then take all the black licorice stuff and then give it to some friends who really do like black licorice. So thank you again for bringing this all the way from Germany for me, and it was a pleasure to meet you and chat with you at the VCF event. And let's move on to the next item. The next thing we're going to take a look at is this copy of IEEE Spectrum, and this was given to me, I'm pretty sure, by John in Arlington, Texas. Now, I covered up the address label that was on here, had his original address. I think he said he moved, but just in case, I've covered that up. So the IEEE Spectrum is generally for electronics engineers, but take a look at the article that's in here, Design Case History for the Commodore 64. And this magazine is from March of 1985. Now, I did a quick Google search, and it looks like you can find at least the article on the Commodore 64 online. I'm not sure about this entire edition of the magazine. So if you want to read this yourself, you can absolutely do it. But just opening the magazine right away shows us inside the bread bin there. And I have to admit, I have not read this article yet, but here it is, Design Case History for the Commodore 64. I'm not going to go through and read this entire article here, but it's cool. It has photos of the die. Here's the VIC-2, for instance, and it actually shows what the different blocks are inside the IC. And it looks like it's a pretty comprehensive article here on a rich collection of graphics modes and the different color modes, and of course the sprites. And we got game screenshots showing off, looks like summer games and Impossible Mission here. And there's the inside of those machines. It's cool seeing something that was at the time just a few years old, and now every time we look at one of these old bread bins, we're looking at something that's really, really old. But look at it, it looks basically exactly the same here. Even this little piece of copper tape used to cover the cardboard RF shield or connect the cardboard RF shield that flops over the motherboard, just grounds it to the shell there. And they're showing the Rev A one here over on the opposite page. It just says old there, and on the other one, if you didn't notice, new. It looks like they're talking about how the original SIDs were ceramic. I'm not sure I've ever actually seen a ceramic SID. And then the original VICs were also ceramic. And then we also had some models that had the DRAM that was ceramic with gold tops as well. Those are kind of cool to see. Now, in 1982, when the 64 came out, it was pretty revolutionary for something that was as capable as it was for being so cheap. And I wasn't an Atari person back in the day, but I have to think when the Atari 8-bit line of computers came out, that was just absolutely revolutionary compared to what people were used to with the older 70s-based computers, mostly monochrome graphics and pretty clunky sound. But the one thing that Atari didn't have going for it versus the Commodore is the Atari was very expensive. It was a really well-made machine with a lot of expensive aluminum shielding inside. I think it just made it cost a lot. So when the 64 came out, it was just revolutionary with a full 64K of RAM in 1982, and it was only $600 at the launch price, and it very quickly dropped in price. I think ultimately that's what led to the Commodore 64 being so wildly successful. So I'll put a link to this IEEE Spectrum article down in the description if you want to check it out to see why Commodore designed certain things on the 64 the way they did. I'm assuming it talks about it in this article. Now, I am kind of curious to see what else we see in this magazine. This thing is really targeted to engineers, so it's not going to have stuff that's generally things you're going to see in regular computer magazines, like an ad for AOS magnetic analysis program, so looking at like flux stuff, I guess. The TO5 relay from Teledyne, and an ad for the Hyatt Hotel chain. Okay. And an ad for United Technologies MOSTEC. So MOSTEC is not the same as MOS. People get confused. They see chips that say MOSTEC on them, and that is not the Commodore company. And chip out your own niche. And here's a supercomputer you can really afford at $100,000, and this is $1985, so way more now. 64-bit scientific number crunching is now accessible. Yes. Ah, yes, but we have a good old IBM advertisement for the 5170 there. Nice. The AT370, I guess that was designed to hook up to mainframes and things like that. Fortran 77, 20 or 40 megabyte hard drive, compatible with all the thousands of IBM PC programs, only thousands at the time. Could you think about how many programs exist for the PC architecture now? Could we say 1 billion different pieces of software have been written for this? Ooh, that's a pretty cool lab bench there. I like the blue and the white color scheme. Oh, that'd be sweet to have nowadays. I'm sure that was a very, very expensive desk back then. Ah, look at this. An HP portable system with a built-in printer, 3.5-inch floppy drive, and it was 32-bit Unix for under $5,000. It's a full-fledged member of the HP 9000 family, with a 16/32-bit 68,000. So it's just a 68,000 processor, much like the Plexus. Must have had some fancy memory management stuff going on. Came with 800K of standard memory expandable to 5.8 megs. That's odd. Is that talking about the floppy drive or the RAM? The Ultimate Ally, General Motors Defense Group. I guess they made avionics or something? It's just amazing looking through this. There's so many companies that are gone. Kodak, gone. Boeing, still around, but in the toilet because of McDonnell-Douglas merger. Toshiba America making semiconductors. There's no way that Toshiba still makes semiconductors. If they do, maybe in Japan, but certainly not in the United States. Fluke, still around. Ooh, check out that old multimeter, though. That's pretty sweet. Tektronix, local Portland company here. Yep, still around, luckily. I mean, kind of a shadow of their old self, but still making some incredible test equipment. So that's cool that they survived. There's a whole article here on simulation for like flights and stuff. Look at that awesome graphics. I mean, 1985, right? That was really pushing the envelope. Now you look at Flight Simulator on a home computer and it's staggering what it looks like. Ooh, there's a job listing here for the supervisory electronics engineer from 44 to 57,000 per year. Rockwell International, lots of defense contractor stuff. Westinghouse, Hughes. Yep, it's all like aerospace stuff in here. Immediate opportunity at the IBM Research Lab in San Jose, California. Interested applicants, please send your resume. Yeah, don't do that now. That job is long gone. It's amazing to think that there was a time when companies would advertise in the back of magazines looking for engineers and scientists. Yeah, this is just all defense industry stuff back here, Northrop, Harris. And I think we're getting near the end here. It's like, what are these here? Oh, employment opportunities, a whole bunch of them. And look, second last page, an ad for car rentals. You want to rent that Chevy Chevette for $34 a day? And add vision to your PC with the PCI by Chorus. Ooh. 2020 Vision for $500. Quick and versatile, PCI converts your IBM PC or XT into a high-performance image processing system and improves productivity through better communications. Standard EIA RS-170, that just means NTSC but monochrome. NTSC, of course, means color, so that was what the standard was before we had NTSC color. That's just monochrome. Input is EIA RS-170, monochrome or RGB, I guess. Video source, 640 by 512, spatial resolution. So it obviously did, well, it scanned a whole frame, so it was de-interlacing, but it wouldn't support any motion, I'm sure. 2.416 levels or pseudo color, standard 64 level optional. Capture time, 0.33 seconds. All right, for 16 level image, or a little over half a second for a 64 level image. And this took one slot in your PC or XT. I'm curious if anyone has ever used one of those cards. I've certainly never heard of the PCI. So thanks very much, John, for thinking about me and bringing this magazine to VCF. I'm going to stick this upstairs now that I've shown it on the channel here, and I'll read the article when I have my coffee in the morning. I normally just sit there and kind of read my phone, read the news and stuff like that, but it'll be nice to go old school and read something printed on dead trees. All right, next up is this DVD documentary on the Apple Lisa before Macintosh, the market failure or industry changer, ? ClassicComputers.com. Now, I apologize again. This was given to me by a really nice person who had this incredible Apple Lisa display with all these Lisas out and all these custom boards that they had designed for the machine. But when everyone was tearing down their exhibits, they were like, hey, would you like this sealed DVD here? And I said, sure. On the back of the box here, we have a quote from Bill Atkinson and a little bit of copy just sort of talking about, well, that's kind of cool to document the history of this machine that was a market failure, but it came before the Macintosh. And obviously, a bunch of things that were implemented on this were then re-implemented on the Macintosh in a way that improved on some of the ideas that Apple did on this first machine. I like this. Part 1, the Lisa at Apple. Part 2, the Lisa after Apple. And then part 3, the Lisa today, the legacy. I no longer have a DVD player hooked up to any of my, well, widescreen TVs. There's a DVD player down here hooked up to this CRT. But I figured for this thing, I should just peel this cellophane off. You know, do you remember back in the day, when you used to buy DVDs and CDs a lot, I used to have this little thing that you could, it was like a plastic thing with a little blade in it, and you could go and you could run it over the top of a box, and it would cut through the plastic. And remember those labels they would stick on the top of DVDs, like an anti-theft thing? So even if you peeled off the plastic, it was kind of annoying to open them. Actually, I guess it wasn't anti-theft. It was more anti-returns. So if you took the CD out of the box, copied it, or say ripped it by say using your computer or copied to tape, and then tried to return it to the store, they would know because that seal was broken. So I guess it wasn't anti-theft. But yeah, it was always a pain to get those off. So yeah, I had that thing that went, and I had one for DVD boxes as well, because I used to buy DVDs all the time. I got rid of all my physical media a long time ago, which, you know, is sad. I'm not a proponent of what's happening with all the digital stuff online. You know, you buy something digitally, you just have a license to view it, but you don't own anything. And therefore, they can just take it away at any time. Like I see, there's actually a burn disk. So I'm just going to stick it in my lab computer here and rip this so that I can stick it on my Plex and then watch it on my TV. So I'm just going to use Handbrake to do that rip real quick. This is obviously not an encrypted DVD since it's not commercial title. Looks like it's in 29.97 frames per second. So I wonder if it was shot in 24 frames per second, and then they did a telecine process to convert that to 29 frames per second. I think what I'll do is I have a preset here for NTSC DV inverse telecine. I set this up a super long time ago, so let's just start this and see if this results in a file that is actually not bad. If you try to do inverse telecine, which is basically converting 29.97 frames per second back to 24 frames per second, it gets all juddery and looks terrible. If this results in a bad rip, then I'll just rip it again. Oh, and darn it, I apologize. I turned on my wireless mic when I started this recording, and I checked the levels in OBS, and it was all looking good. But I think what happened is the battery died in it, and I just didn't notice because I can see the battery level on a little screen right up above here. And that means that this camera right here is where you'll be hearing that audio from. And it has terrible microphones that sound like garbage. So I do apologize for that, but hopefully it should sound better now. Okay, moving on, we have this. Now you look at this and you're like, I don't get what this is. It's just an ESP32 with a DIN connector on it. Well, yeah, what this is actually a Meatloaf. And what this open source project does is it's like an SDIEC for the Commodore 64. So this plugs into your C64 or any computer for that matter that has an IEC jack. But instead of using a normal SD card, this entirely works over Wi-Fi. And on the website here, meatloaf.cc, you can see the key features: IEC bus interface for loading data directly from flash memory. Oh, it does have some flash memory on this ESP32, I think 8 megabytes, so you can copy stuff onto it. So it can load it via flash memory or HTTP. It can mount the Meatloaf flash file system via WebDAV. So that means that you can run a WebDAV server on your desktop computer locally on your LAN and access everything directly off that. It all works by just accessing the drive, as in drive 8. And you can navigate around, connect to websites, run programs remotely, all this sort of stuff like that. It can also be configured to emulate multiple IEC drives, IDs 4 through 30. Each device configuration is switched out and persistent on access. It also gives you a Wi-Fi modem for connecting to Telnet BBSs. And yes, it is doing that all over the IEC connection. Now, the FujiNet is a very similar product, and Jamie, who is the person who maintains this, actually is working with the FujiNet folks as well. So it's not like this is reinventing the wheel. They're actually working together on the Commodore stuff. And Jamie, the maintainer of this, is constantly adding new features. And one of the really awesome thing that he actually showed off 2 years ago to me, he's been working on this project for a while, is a plugin. I think it was a Firefox or Chrome plugin. And you could go to any website that has D64 images, and you can, with this plugin installed, you can right click and say send to Meatloaf. And you have the plugin on your computer configured for the ID of your Meatloaf device. And then what happens on this is you can just type load, and you can just load the thing you right clicked on from that random website. Like say you're on CSDB, and then it loads it right up on your Commodore 64. It is so cool. There's no need to then have to take that URL, download the file, copy it onto your SD card, stick it in. No, none of that. It's just all automatic how you can just send it right from a modern computer to this. Since Meatloaf is an open source project, of course it's on GitHub. So if we take a look here at the repo, there's just a bit more information. Yep, supports multiple virtual devices, emulates a floppy drive, allows you to connect to the internet, and it actually allows programs to connect to the internet. So cloud disk drive, we already talked about that. You can load stuff directly off a URL or WebDAV server, but you can also access web resources right inside programs. And I think there's already a few things that have been coded for this that are also things that are on the FujiNet, like the ISS real-time tracking program. So I'm assuming it uses this type of connectivity here to interact with a server somewhere that gives you real-time location on the space station. And there's a little bit of a wiki here, which talks about how you can mount this thing either on a little board that plugs into your user port to supply power to it, or you have to power it up via USB if you just have a little standalone board like I have. 3D printed case for it. And then the instructions on how to connect it to your Wi-Fi. You just do that on the Commodore itself, and then you can test connectivity that way, and then we can load some stuff. And what's really exciting is there's nothing custom right here. This is just a normal off-the-shelf ESP32. You have to buy the right version though. I think it's a bit confusing. There's a bunch of different versions. But with the right board, all you have to do is just solder the wires directly to the pins, connect it to your 64, and you're off to the races. All right, my ZIF 64 is here on the bench. Let's see if we can get this thing working. Oh boy, my 64 has issues. The ZIF 64, there's something going on with this ZIF socket here where the keyboard 6526 is in, and you get that. You get lots of random junk on there. It's the socket is going bad. Okay, we should be all connected up. I went back and typed in a bunch of junk over the SSID info there, so we don't see it. And yeah, I was in lowercase mode because the password has uppercase, lowercase. Now, theoretically, it should be able to connect, and I think the command on the wiki said to do this. And this should load something off of somewhere. So let's take a look here at what this is doing here. Oh yeah, look, there's a whole bunch of stuff on here. The implementation of IEC on here does not yet implement the Jiffy DOS protocol, so we're not going to get the speed up that Jaffy DOS, which is just a patched version of Jiffy DOS. And navigating around, there's a whole bunch of games and demos and stuff. And now this is just like a default. I think this is actually pointing to Jamie's server that he runs, probably something in Amazon. Let's just try loading pacman.prg here. Obviously, I could just point to any URL at anywhere and load any software, or use the browser plugins to then point something directly to the Meatloaf ID and then load that much more quickly and easily. Now, I loaded pacman.prg. I don't know how large this file is because this file browser doesn't show us the size, but it's taking a little bit of time. And this machine would have the normal speed up of Jiffy DOS, but like I said, not implemented yet. But that is coming. It's absolutely something that Jamie is working on. Now, the reason why you see this little cable sitting here is I was originally powering the Meatloaf off this, which was fine. But then I wanted to check out the serial debug output on it because it does show up as a COM port, so you can look at if your Wi-Fi is not connecting or something like that. And, oh, that didn't work. Okay, well, that's funny. Anyways, turns out that this is a charge-only cable. It doesn't have any data lines in it. Piece of junk. So I hooked up with another cable here, and then I was able to look at the serial debug in PuTTY. So what exactly is wrong with this? Why doesn't it work? I don't know. This is not a problem with the Meatloaf. This is a problem, I think, either with my C64 or the game we loaded. Look, it worked anyways. There's no sound hooked up right now to the machine, which is why we're not hearing anything. But there's Pac-Man loaded right off the freaking internet. How cool is that? Does this work without a joystick? I don't think it does. I'm not familiar with this version of Pac-Man. Is this the actual original because has scrolling? I don't know. I don't remember ever seeing a version that scrolled up and down. So it's kind of a nice implementation and a good, what do you call it, workaround to the fact that the arcade machine had a CRT that was turned on its sides. We had more vertical pixels than something like the 64 can display. Anyhow, there we go. We loaded something directly off the internet. All right, what I'm going to try to do is I'm going to try to load the 8-Bit Dance Party directly off the internet here. And this is a long URL to type, so we'll see if this is possible. I'm going to get a close quote, comma 8. Maybe? Let's see if this works. Hey, it says loading. So that works. That's where the plugin comes in handy, right? So you don't have to type the whole stupid URL. You just right click, send to Meatloaf, and I think what you do is you load ML something, maybe nothing. I can't remember how it works exactly. Jamie demonstrated it to me, and it was pretty cool. I really just hope that the speed up code for the fast loader of Jiffy DOS can be implemented, because I kind of forget how slow IEC is without any of the acceleration. Okay, I've gone ahead and I hooked up the audio cable, so hopefully we have sound. Let's type run. There it is. It freaking works. Loaded directly off the internet. How cool is that? It's been a while. It has been a while. I haven't done any Commodore 64 content in ages. Anyhow, that is freaking awesome. I absolutely love that. I mean, it's really bringing the 64 into the modern era. And as I mentioned, this is absolutely the code that's going to be used or shared with the FujiNet project. So yeah, no wheel reinventing is happening here. And all of these cool features are, well, I think going to be available on the FujiNet. I'm not 100% sure on that, so don't quote me on any of that. But the Meatloaf project itself is always something that you can just build yourself. So go to the URL for the GitHub repo and look at which ESP32 you need to buy. Pick up one of those, pretty inexpensive little board there. You just load the firmware onto it, solder on the DIN cable, and there you go. You're up and online with your Commodore 64. Absolutely awesome. So thank you very much, Jamie, for building one of these up for me. Even though it's so easy, I kept ordering ESP32s and kept ordering the wrong ones. You have to order the specific models that's mentioned on the GitHub repo. So thanks, Jamie, for giving this to me. And I'm really looking forward to seeing where this project goes, especially once the fast loader stuff is implemented and then this code gets added into so many of the other projects that are floating around out there. All right, well, it looks like the Lisa documentary finished ripping. So the file's right here on my desktop. And I should just take a quick look at this and see if I did the right thing by doing that inverse telecine. Taking a look at this, I think I shouldn't have done the inverse telecine. That's still totally watchable though. It's difficult with DVDs. A lot of times when people author these, they don't know all the ins and outs of interlaced video, especially if they've recorded the video on cameras that say were set for 24 frames per second, and they're just using a video editing package that can output a DVD type image, and the frame rate's set to 29. Is that inverse telecine or not? You know, who knows? And ultimately, when you're playing this on a DVD player on a modern TV, they're pretty good at doing the deinterlacing in real time and, you know, getting things mostly right. What I should have done is just looked at a little bit of the video here and just looked for any motion in the video and looked for the 3:2 pull down that's happening when you're converting 24 frames per second back to 29 frames per second. And that's what we were trying to reverse with that handbrake decode that I was doing. Anyhow, even though the file may be converted incorrectly, it's still totally playable, so I'll stick it on my Plex and I'll watch it when I have a moment. All right, moving on to more things I brought back from VCF. So we have the 6502 software gourmet guide and cookbook. I can't remember if this was John who gave me the IEEE Spectrum magazine who gave me these as well. And if it was, thank you. And if it wasn't, I apologize. I didn't seem to have written down on here anywhere who gave me this and this very handy instruction handbook. I am no assembly language expert, but it's handy to have little books like this that you can just quickly look up, like the push the accumulator onto the stack, PHA, just like see how that works exactly. Instead of having to Google or look online for every single little thing, sometimes just having a little book like this is so super handy. And I actually have some of these similar books that just I keep handy on the side here. So we have Motorola MC68000 Programmer's Reference Card. This is really tiny text, so it's very difficult for me to see with my current glasses. I'm going to need some stronger reading glasses, but nonetheless helpful for quickly looking things up as well instead of having to search online. I have this here, the developer solution, the ASM86 pocket reference system for DOS. So this is really just like 8088 and 8086 instructions and other things I had sitting on the bench, a little reference card for the 6809. And then we have this thing here, which is the PCXT80 handbook. I think everyone kind of remembers these. These just have tidbits about stuff to do with the old computers, like IO maps and things. And it's handy to look this stuff up really quick in a book like this, as opposed to needing to go Google for everything. Everything that's in here is available online. It just takes quite a bit of time to find it. And when you have something like this, oh, you need, to program the CGA card, for instance, easy peasy. EGA, VGA, all those different registers and stuff. And yeah, it's pretty handy. These are always kind of neat. So they're a bit dated, all of these things. But I will be definitely keeping the 6502 one with this little stack, because I don't have one now. And that's pretty awesome. And then this will go on my bookshelf for when I finally start to decide I want to learn assembly language programming, which will be at some point in the future when I have way more time on my hands than I have now, which is basically none. And next up, we have this little thing here, 99.9 fine gold load runner. Now there's something floating around inside of here, and hopefully I can just pop this off. Now someone at the show gave this to me, and oh, it's a little speaker. How cool. Okay, a little hot glue, that didn't stick. So we have a Raspberry Pi Pico RP2040. Yeah, not the second generation, but the first generation. I'll need to re-glue this in somewhere. This was probably just stuck on the SoC there. Not sure exactly. Anyhow, what it looks like this is a little all-in-one computer. We have video output, VGA, we have a PS2 keyboard port, and it looks like we have a serial port, and then the power input right here on the Pi Pico. And then over here, I don't know if that's Ethernet or another serial port. And then we have an SD card slot. Now inside the binder, we have some information from the developer of this particular project here. And yeah, this is the Badger 6502 Pico from Eric Badger. There was email address stuff here, which is why I've taped over that. Parts and assembly for the V2 eBadger 6502 Pico. So Raspberry Pi Pico, yeah, we have all the parts here necessary to build this, an LM386. The 9-pin port was not serial, it is a joystick port, and I'm assuming the RJ45 is actually a serial port. And it looks like there's a version 1 as well. And the note, which is not personalized, is just came with this. And I guess if you were to purchase one of these kits, you'd get the same note. But thank you for purchasing the Badger 6502 Pico and for your support. It's a kit form. See the parts list, ericbadger@gmail.com. So I guess Eric's okay with that one being out there since it's in the welcome note here. And if we take a look at the required hardware, we need VGA, PS2, micro USB cable, not included, apply power. A micro SD card is required for the drive emulators for level editing and for loading and saving basic programs. So I'm assuming this is going to be running a port of LoadRunner, hence what's going on here with the little artwork on there. What's included here is an original and custom 6502 emulator. Specification matches the eBadger 6502 computer. Oh, right, the eBadger. I'm editing the video right now, and I remember after I shot this footage that when I was talking to Eric about this project, this whole thing stemmed from Ben Eater's 6502 computer kit. Eric was really intrigued by this and decided to go build it up, and then he wanted to start adding extra functionality to it, specifically adding keyboard capabilities and then storage, and then adding video to be able to port something like LoadRunner directly to it. Unfortunately, things started to get really out of hand with the size of the breadboard project trying to add all the peripherals. You can see the VGA adapter just sort of hanging off right there. And Eric mentioned, and it's all in this video here, which I'll link down below in the description, that it just got out of hand and really was super unreliable the way it was working. So as a first attempt, Eric designed a PCB to offload some of that stuff off of breadboards, and that became the Badger 6502 project itself. And getting rid of the breadboards actually brought some stability, so Eric was able to start porting stuff to this retro computer, the Badger 6502. And then this project was born. Eric condensed the entire Badger 6502 down to run on a Pi Pico, and I guess it's actually software compatible. So the LoadRunner that you're going to see demoed on this thing, I'll run this in a moment, is actually the same code that was running on the full-size Badger 6502 machine. It's an Apple II port of the game LoadRunner to the custom computer, includes a working level editor with save capability to the micro SD card, saves the high scores as well onto the onboard flash. Microsoft Basic, which is Commodore version 2.0 compliant, or variant that is, with save and load capability, and the WAS monitor, the Apple I machine language monitor written by Steve Wozniak. It includes an original Atari disk drive emulator. It supports SD, ED, it's enhanced SD, and double density disks. Supports the ATR images up to 16 megabytes, and a Commodore serial IEC disk drive emulator. Currently alpha support, your mileage may vary. Only supports read and raw access, does not yet support formatting. My assumption is this is not a regular RS-232 serial port, that this is a TTL level serial port, which means that it can communicate directly with the Atari SIO ports and the IEC ports. Cool. Known limitations: if you try to power this up without an SD card, it will try to read it, which would take about 30 seconds. So good, I will know that. I just need to wait. Commodore drive emulation is not yet complete. Work in progress. The drive emulation is better, but does not support these other types of file formats. As of now, it's not possible in BASIC to control the graphics or switch into graphics mode. This could change at a future time. Device will boot directly into LoadRunner. Has a similar control scheme to the original Apple II, U and O to dig left and right. Control A to kill, R to terminate, and M for the high scores. And there's also a cheat, Control N for next level, Control E for extra guy. Warning, cheats will prevent saving the high score. That's cool. We can switch to the WAS mod by pressing Control Delete from LoadRunner, or switch to drive emulation by pressing Control Alt 2 from the WAS mod. It won't work from LoadRunner, and the drive emulator for the Commodore is Control Alt 1. We have a bit of a memory map, because remember, this is a custom 6502 computer, so 48K of RAM in this space here, all the way to BFFF, very similar to the Apple II, which also has like device stuff up in the C space. We have the normal location for 6502 vectors here. That's on all 6502 based systems. WASMON sits all the way up at the very top, and there's a bit of an OS and the basic ROM. There is a speaker beep, which we do have the speaker in here, which I assume is used for LoadRunner, right? That's probably making the sound from the Apple version. And you can also control the GPIO lines. Eric has a GitHub repo that contains the version of WASMON and Microsoft Basic that's been ported to this thing. As of now, this is only good for code inspection, as the Badger Pico project, which obviously is what we have right here, is not yet published. So I guess this is a pre-release. I think Eric told me some of this stuff, and I completely forgot about it because it's been months, right? We have another project here, Badger Frauds, port of the PCZ machine emulator Frauds to the Pi Pico. It's designed to run on the eBadger 6502 Pico hardware and could serve as a useful guide if you'd like to adapt the hardware to some other project. All right, so we have the PCB layout here for what's in this little project, and we have some schematics here. So I'm curious about the serial port here. Let's just take a look at here. Yeah, so this connects directly to the GPIO line, so it is TTL 5 volts, or I guess it's actually 3.3 volts. But the RP2040 is 5 volt tolerant, so even though it's outputting 3.3 volts, you can send 5 volts into those lines, and it is just fine. There's the joystick port, PS2 port, that's connecting directly to the Pi Pico, and the VGA port looks like it's only implementing 8 colors, because I don't see any resistor ladders doing any kind of division. So the analog is just I guess 3.3 volts. There should be a resistor there, and that's because VGA really wants 0.7 volts per line, especially if hooked up to a CRT. Is there anything on here? Where's the video connector? There it is. No, it's wired up directly. So that is not ideal. Yeah, you really should have dropper resistors bringing the 3.3 down to 0.7 volts, even if you're just going to drive this directly. Now on something like a CRT, I think that might pose a bit of a problem. You might overload the input buffers, but on an LCD monitor, I'm sure it doesn't matter at all. It has some kind of input circuitry anyways that will just clamp those. But yeah, on an analog monitor, I wouldn't really recommend plugging a regular CRT into this project because of the way the VGA is wired up. And we have a couple basic programs for testing out things. Buzz from the speaker, so I think it works a lot like the Apple II, where you just poke a value or peak a value and you get a click out of the speaker. So if you do that quickly enough, you get tones. Blinky, last key, just for reading the PS2 stuff. And that's really it. So let's give this thing a little test. I don't have the hot glue gun wired up or warmed up, so I'm just gonna use a little piece of tape here just to tape the speaker down so it doesn't short on anything. We'll grab a PS2 keyboard here. We don't need the 9-pin adapter, that's very stiff. And we'll plug this into here, like so. We'll plug in the VGA capture device here. And I'll be powering this off this little power bank right here. So let's switch over to the VGA input on the capture device so we can see what this is doing as a boot. Okay, I think we're looking at the Extron, so that's the VGA connector. Let's see what this does. Power up. So far, nothing. It's possible the Extron wants 5-volt sync levels. And it may not be getting that from here because, oops, there's no image to auto sync. We'll just wait because it said it takes 30 seconds potentially for something to appear. Oh, there it was, load runner. Right. So totally working, And keyboard doesn't work though. Oh, the sound is working. So definitely an Apple II port with that circle going in and out. I remember when I was a kid, I played a lot of Load Runner, and boy, did it drive me crazy. Wow, what's going on with the keyboard though? This is plugged in, and this keyboard absolutely works. It's just a, it's a modern thing, obviously. I, K, J, nothing. Arrow keys, nothing. I guess I'm gonna grab another keyboard. All right, we have a bog standard like HP keyboard here. If this thing doesn't work, the lights flashed on the keyboard. That works. I wonder why it's not working with that other keyboard. Oops. Okay, I was looking at the screen. Okay, definitely can type. Let's try that again. So the 8 colors are interesting, right? We don't have the standard Apple II color scheme. Oh, and as I was saying, it was really annoying. I don't know what's happening now. The light's blinking. It was really annoying when I was a kid with this game because every time you would die on one of the hard levels, the animation was so slow to go like that and then open up again. And I know other people were annoyed by that because there was a patch. Oh, there we go. It just took a while to reload. There was a patch that someone made that got rid of that stupid animation. And here we go. Let's start the game again. Okay, I think I have my bearings now. Let's try this again. So, yep, I can dig that way. So, and as I was theorizing there, I wonder if the graphics subsystem works in a very similar way to the Apple II, where the graphics modes are kind of interleaved. Oh, dear. Oh. No, no, no. I'm not a bad Load Runner player. It's just talking and trying to look at the OBS capture and use this keyboard where I'm not familiar with the... how do I stop? Okay, I can use the space bar to stop. I kind of like my talking is interrupted constantly. Yeah, I really wonder if the graphics mode is very much a re-implementation of the Apple II graphics mode. Kind of have a feeling it is. That would make this port much easier. Okay. Yeah, the keyboard layout is a bit different than the way it would be on an Apple II, an actual Apple II. It makes playing a little more difficult. There we go. Like to go down, you push the J key, and I think on the real Apple II, you actually push the M key to go down. That's what I was pushing originally and struggling with. Oh, yeah, the layout is just weird. I'm not used to it. It's actually the same layout as WASD, but it's the IJKL. Why isn't it just WASD? That would have been much easier to use your left hand for controlling the guy. Anyhow, there it is. Okay, so how do we get into BASIC? It was Control-Alt-Delete to get into the WAS monitor. Is that what this is? I guess. I don't actually know how to use the WAS monitor. It says here in the manual, to switch to BASIC, type C100R and press enter from WASMon. C100R. Oh, there we are. Commodore BASIC. Yeah, 45K free. It's funny, there's no cursor. Now, at least with the firmware that's on here, as Eric pointed out, there's no way for me to run any kind of graphics modes on here. But what I can do is I can type in the fractal basic benchmark that I've used in a bunch of videos, and we'll see how quick this is. In fact, let's just do a little program as a test. Hello world. And we'll just see how quick or slow this actually is. Okay. I don't even know if we have more than 80 columns of text. It's unusual. There's like an extra character off the edge of the screen there in the bottom corner. Control C does stop though. Yeah, okay. So I have my little fractal basic program here. I'm just going to quickly type this in and we will see how fast this actually is. Can I push backspace? Yes, I can. So that means it's already better than the Apple II because you can't use the backspace key on that. Hopefully this has floating point. It says it's Commodore BASIC compatible, so it should have floating point. All right, there it is all typed in. I don't know if I did it properly or not. Let's hit run. Okay, it's going. Looking at the speed that it's running at, I'm going to say that this is roughly the same speed as, say, an Apple II, which is, pretty slow. I should probably time this benchmark, so we'll start again and I'll get my stopwatch ready. So I'm going to hit enter and press the start button. There we go, and we'll see how long this takes, and then I can compare this to all the other machines on the spreadsheet. All right, 6 minutes, 53 seconds. That's what we got. 6502 Pico, Raspberry Pi, RP2040, 6502 core. This actually took 413 seconds to run, and that is actually somewhat speedy here. Stock Apple IIe, 489 seconds, so it is a little bit faster, although different version of BASIC, remember, so we can't really compare it apples to apples. There's a big difference between one version of BASIC and another, even on the same exact hardware. We can see here that BBC BASIC on a 1 MHz 386SX, this is some benchmarks that I did in the past when I was preparing for that 286 1 MHz video. That was 479 seconds, so slightly slower than this thing. We can see here that the Nabu computer does this in 320 seconds. That's using MBasic, which I think is very similar to the BASIC that's been ported to this thing. But that's running on a 3.58 megahertz Z80. Meanwhile, the Mega 65 in 1 megahertz mode runs it in 295 seconds. And then an Apple II GS in fast mode, 181 seconds. So quite a bit more speedy than the Apple II in 1 megahertz mode. Anyhow, this is a pretty nifty little project. It's cool to see an entire computer emulated inside something that's so inexpensive as this. And to think that if you had a custom PCB with RP2040 right on it and manufactured it in China, you could probably make the entire thing, at least the PCB with all the components, for just a few dollars. So I think Eric's idea for making this particular project was to really just see if you could do a whole 6502 core on a Raspberry Pi Pico and all the peripherals. And obviously, it's totally possible. So hopefully this opens the floodgates for more cool projects like this. And maybe someone can get an entire fully compatible Apple II running inside this thing. That would be awesome. And then use the SD card for drive emulation. Is the Pi Pico powerful enough to do all of that? Maybe, with the right clever programming. So if you're interested in maybe talking to Eric about this, I'll put some links down below to the GitHub repo and you can reach out, talk about this cool little project. I'm not sure where you can buy this kits. I didn't see anything on Eric's website about that, but obviously if you're interested in getting one of these to fool around with it yourself and potentially change the firmware and stuff, then yeah, reach out to Eric, and like I said, there'll be links down below. All right, next up we have these little PCB adapters. These are all for the TRS-80 Model 1. A few of these, I have a whole bunch here. A few of these, I think this one right here, this replaces the character ROM or the character generator on the original Model 1. It's a weird little custom chip, I think made by Motorola, that's not easy to find, and it replaces it with just a standard EPROM. It's a small dip package, the original one, and then the new one is just an EPROM footprint, of course, for a socket, and then we have some space for jumpers and things that allow you to switch to different character sets. And the one EPROM can hold a whole bunch of different character sets, uppercase, lowercase character sets, plus some other graphics ones and different fonts and stuff like that. And this is very handy for me because I have at least one Model 1 that has the old character generator that's just uppercase only. And that means that a lot of software doesn't work properly on it because it tries to display lowercase characters and you just get a bunch of garbage and stuff. So this will allow me to get those working. The other little PCB that's on here is a ROM adapter to replace the standard ROM that's on the TRS-80 Model 1 with a bigger EPROM. And I think you can eliminate that entire extra little ROM board that's with a ribbon cable, and that whole thing is very flaky. Now, all of these little PCBs come from RetroStack, who had an awesome display at VCF in Dallas. And I want to show some of the amazing stuff for the TRS-80 Model 1 available from RetroStack. So this stuff is all open source, which is even more amazing. But so there's Shop RetroStack. So Shop RetroStack. I'm just going to go right here. So here's the character generator thing I was talking about. So that's the PCB. Oh, it's not jumpers. You mount some switches, and that plugs into the old socket on your Model 1. Allows up to, I guess, 30 character sets. Okay, that's kind of cool. So you can buy a fully assembled one. There is a replacement keyboard for the Model 1. That is, yep, Cherry MX, fully assembled, $154. Doesn't even seem that bad for a complete replacement keyboard, because honestly, the Model 1 keyboard, at least the ones that I have, are stack pull, are horrible key switches. They start to break and fail, and here's a complete replacement. Now, you might be wondering, an entire replacement keyboard? Yes. Well, oh, there's a kit you can buy as well. The reason why is that you can build an entire Model 1 now with replica parts. Everything is available now. So the PCBs, here's the ROM set adapter. So I think I have a set of these as well. So that allows you to change out the ROMs. The weird button that's available. Now, what was also at the show, and I didn't even get photos of this, unfortunately, were entire replica resin printed cases that looked so good, like completely awesome looking. And then there are replica motherboards you can get. So we can go here to this repo, and there it is. That's the replica motherboard, fully assembled. And the reason for these little adapter PCBs is you can't really get the old ROMs anymore, and you can't get that character generator anymore. I mean, they're very hard to find, so hence the need for these adapters. Everything else on here is completely off the shelf. So with this replica PCB and, of course, the replica keyboard, you could make an entire Model 1. You just need a new case, because unless you have an extra case without a motherboard for some reason, there are the replica cases as well. Now, this is all open source, so you can get Gerber files, so you can make these yourself. All the schematics are available for the replica, assembly guide, there's the PCB. This stuff was being sold at the show, but it doesn't look like you can actually buy this stuff here. You have to make it yourself. But a very comprehensive guide here on the entire bill of material, on how to submit the order for the PCBs. Let's see, central page for the Model 1. Let's see what else here. So we have the Model 1 motherboard, the keyboard. We have a power supply replacement as well. Let's take a look at that. Yep, there it is. That's so freaking cool. Replacement parts, let's see, printable parts. What is this exactly? Oh, look, it's the case, the main enclosure, the little plate on the back, standoffs, so you can, that sits under the motherboard, so it like sits in the case properly. Keyboard, oh, really? Replacement stems? That's not 3D printable, is it? It is? What? I'm completely I'm amazed. There's no way my junky printer would actually do that properly. Clips for the space bar. I mean, everything has been recreated. Everything to fix up an old Model 1 that's missing parts or has broken parts, all the way to the entire computer. So yeah, there's the entire bezel as well, the two different versions, one with a number keypad, one without. I mean, unbelievable. And then you can order these at JLC. They do a really good job of the printing. I saw some on display there to show. I was completely amazed. You can tell it's not the original. You know, it's not exactly the same. The design is exactly the same. But my point is that it's such an authentic replica. So if you have a Model 1 and that bezel's missing or broken or whatever, you can totally make one here. This whole project is so incredible to me, and it's all open source. It's just so cool. So I guess, yeah, there's the original case, you know, ratty a little bit. And is this one of the 3D printed ones here? Yeah, this is a 3D printed one. There it is, side by side. Look how good that looks. I think it's been painted, you know, with some silver paint, because I don't think it necessarily comes out of the 3D printer looking exactly like that. But I mean, yeah. Yeah, I saw them at the show and I was completely blown away. So if you have any need for any Model 1 parts to get it up and running, or you want to create an entire replica, you can absolutely do that here from RetroStack. I'll put links to these repos down in the description below, and yeah, go check it out. I was super duper impressed, and I really appreciate getting this little pile of these PCBs here, so I can finally get around to fixing up that TRS-80 Model 1. I think it's upstairs in my office. I have a little box that I keep off to the side here, and in this box I got PCBs, lots and lots of PCBs. It's a PCB way box because I printed some at some point, but it's totally full of stuff that people have sent, like a CPU relocator here for the Amiga 1000. So these are going to go in here for now. Oh yeah, okay, so it says RetroStack on here. That means that when I go to build these, I'll be able to go look up the projects on GitHub and know how to build them. The one for the ROM actually has a little tiny IC that mounts underneath the socket for the ROM. So thank you very much, RetroStack, for doing this incredible project and putting it all on GitHub as an open source thing for anyone to make, and basically making it possible to completely replicate the TRS-80 Model 1. I completely flabbergasted at how freaking awesome that is. And thanks for the PCBs as well. At this point in the video, I just want to do a mini wrap up of VCF in Dallas. I had an absolute blast at this event. Thank you for everyone who came up to say hi to me, and I'm including a few pictures of some of the stuff that people sent in. If you did get a picture with me, feel free to send it in. I'd love to keep it and save it just as memories. And the whole event was amazing. I thought the crew that put on the show did a wonderful job, and it was really fun just experiencing all that retro. And it's always amazing to meet my fans and meet other people who are into this retro stuff. So if you haven't been to a VCF event, I highly recommend it. It's an absolute blast, and you're almost certainly going to have a wonderful time. As a reminder, I'm going to be at VCF Midwest in Chicago coming up in September. So if you happen to live nearby, I highly recommend you come to that show. It's absolutely off the hook. It's so great and so big. And I'll actually have a table this year. And I think that is going to be it for this mail call video. I thought it was going to be pretty quick, but I think it kind of went on for long enough because as usual, I like talk so much. So if you're new to my channel, you might not realize that I do these mail call episodes and I try to show the stuff that people send in, and I try to do a little bit more than just like, oh, here it is, and then move on to the next thing. And that's why these episodes can run and be kind of long. So anyways, if you liked it, thumbs up. If you didn't, you know what to do. Thanks for my patrons. Names are going off the side of the screen, and you know, all the usual YouTube stuff. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.